Good afternoon, distinguished colleagues. May I declare the Dissertation Board for the PhD Award Candidate of Sciences to order to consider the dissertation submitted by Yana Safonova, application of graph models to bioinformatics analysis of highly variable biological sequences in the subject 051318 mathematical modeling, numerical methods and complexes of programs. I urge the audience to switch off their mobile devices. Thank you for compliance. The defense is broadcast live on St. Petersburg University website. Simultaneous interpretation into English is provided.
Хочу отметить, что согласно федеральному закону
May I inform you that according to federal law 148 FZ as of May 23, 2016, revision of Provision 4 of the Federal Law on Science and Research Policy as of August 23, 1996, number 127 FZ, St. Petersburg State University and Moscow State University have been granted an exceptional title to independently award scientific degrees. Hereby, scientific degrees are awarded only in the subjects and scientific areas contained in the relevant scientific subjects register issued by the Russian Ministry of Education. A relevant decree number 6821/1 on the PhD awarding procedure in St. Petersburg State University is effective as of September 1, 2016. May I inform the audience that according to paragraph 17, section 3 on the rules of the PhD granting procedure in St. Petersburg State University, the thesis board is not considered legitimate unless 2/3 or over of the appointed composition, but no less than 4 members, are present at the meeting. Today, the composition is 5 members. Correction, 2 members. Those are Professor Ovsyannikov and Chair Yegorov. There are 5 members overall, and 3 more members will be together with us online, and we have a conference connection with them, which means that we have a quorum. According to paragraph 19, section 4 on the thesis council meeting of the aforementioned rules of procedure, the time limit of the meeting is as follows. Well, we will be doing our best to round up in 2 hours, but, well, we will follow the due course. Number 1 on the agenda is a brief report of the chairperson on the documents submitted by the defendant in compliance with the requirements. A Q&A session to follow. A brief report of the defendant on the findings of the research. 15 minutes maximum. You don't mind? No objections? No. Colleagues, do colleagues that are together with us online, any objections? Third, questions as to the defendant's report. 2 minutes per question. And defendant's replies. No objections? Presentation of the reports submitted to the Dissertation Council. Members of the board take turns to announce their reports, focusing on elaborate argumentation behind their assessment, as well as questions and suggestions addressed to the defendants. 10 minutes per each member. I have a suggestion to the distinguished members of the dissertation board. It is as follows. All the reviews were timely submitted and published on the website. So probably, but that's, well, again, this depends up to you individually, but probably we won't be reading out the entire text of the report. And we'll do just an oral presentation of the report, just focusing on the key advantages and some comments. And the most important words, please don't forget them when you are finishing your report, whether the thesis complies to the aspired academic degree and the subject of the thesis. Well, next on the agenda come general commentaries of the defendant addressed to the members of the board. 6, open discussion and statements by members of the audience who are not members of the board. Only strictly relevant suggestions, questions, and feedback addressed to the defendant are accepted. No more than 5 minutes per each speaker. All willing to take the floor should register in the registration list beforehand. May I urge Tamara Guramovna to register all those who are wishing to take the floor from the audience. Please introduce yourself before making your statement. 7, defendants reply to statements of the audience who are not members of the dissertation board. 5 minutes maximum. Statement of the research supervisor. Is the research supervisor, is the mentor here? No? He's not with us, but do you have a mentor? Do you have a research supervisor? Yes, you do. Okay. Then I will read out his review. Number 9, 5 minutes break before open voting on awarding the defendant with the aspired academic degree. The discussion, I should note, between members of the dissertation board is not broadcast online. So the audience may leave the room, but the members of the dissertation board will be working, they will be discussing the thesis, the performance of the defendant, and will finally deliver their final decision. Then we are going to have online broadcast resumed, and members of the audience are invited back into the room, and the count of vote and the registration of voting results will be done. Pass or fail, they will decide, and this is going to be the decision, and the concluding remarks by the defendant. Now my report. The dissertation submitted by Yana Safonova in this subject, Mathematical Modeling, Numerical Methods and Complexes of Programs, under the title Application of Graph Models to Bioinformatics Analysis of Highly Variable Biological Sequences, was approved for defense under decree number 968/1 issued by the director of the St. Petersburg State University Defense Supervision Center as of January 31, 2017. The composition of the dissertation board was approved under relevant decree issued by the director of the St. Petersburg State University Defense Supervision Center as of January 31, 2017. The composition is as follows. Nikolai Yegorov, Doctor of Physics and Mathematics, Head of Department of Electronic and Computer Systems Modeling, Chair of Dissertation Board. Dmitry Ovsyannikov, professor, doctor, head of the Department of Electric and Physical Systems Theory and Operation, St. Petersburg State University. Dmitry and me are members of the operating thesis board in St. Petersburg State University under this very subject. Stephen O'Brien, PhD, head of the Dobrozhansky Center for Genome Bioinformatics, St. Petersburg State University. Dmitry Chudakov, Doctor of Biological Sciences, head of the Adaptive Immunity Genomics Laboratory, Bioorganic Chemistry Research Center, Moscow. Siavash Mirarab, PhD, University of California. The defendant, Yana Safonova, has presented the full set of documents required and in compliance under the decree 6821/1 as of September 1, 2017, on the PhD granting procedure in St. Petersburg State University. Do members of the board have any wish for me to list all the documents? No objections? Okay, I won't list all the documents. It is so decided. I should note that all the documents submitted by the defendant are in compliance with paragraph 12, section 3, presentation and submission of the dissertation. Are there any questions, any housekeeping questions or issues that are still not clear? I don't see any questions. So, may I now proceed to the very essence of the defense procedure? Yana Safonova, Madam Safonova, the floor is yours, 15 minutes maximum. Distinguished members of the dissertation board, distinguished members of the audience, it is a pleasure for me to be here and to share the findings of my dissertation under the title Application of Graph Models in Bioinformatics, Analysis of Highly Variable Biological Sequences. My thesis is devoted to 3 sequences, the DNA, the RNA, and proteins. Those do the key function in a living organism. The pivotal property of these molecules is that they are assembled from elementary units, nucleotides. This allows their presentation as a sequence of letters. For example, the DNA has 4 letters, and you see them on the slides, and the same is true about the RNA and the proteins that are composed of 20 amino acids. And despite the fact that the RNA, the DNA, and proteins have bidimensional or tridimensional properties that modify their behavior, this is an established fact. However, the sequences of letters alone disclose ample information to understand these processes. Sequencing is a process to determine the succession of letters in the DNA, RNA, or protein structure. It was first suggested by Frederick Zenger in 1977, who was later awarded a Nobel Prize. It was indeed a breakthrough in biology. And today, sequencing is a vital stage in biological research. Over the last 40 years, a lot of companies have entered the market of DNA sequencing products. And here you can see some names of these companies that produce sequencing machines with unique processes. But the process is, however, the same in its essence, because what we have is multiple reads. Every read is a short block of sequence sequential information, short reads do not come with any information as to the position and can have sequencing errors. Therefore, the objective of genome assembly is to recover the original DNA sequence as accurate as possible. So all these properties are very difficult to formalize. Therefore, all the algorithms are heuristics. One of the algorithms is called the De Bruijn graph. Initially, it was applied to solve different challenges. But what I'm talking about is De Bruijn graph in bioinformatics. So we identify all the unique k-mer reads, and these are going to be the vertices. And then two vertices are connected with a directed edge if some read has a length of k plus 1. Prefix is its starting vertex, and its suffix is its end vertex. If sequencing was flawless and covered the entire starting DNA, it matches the path of the graph. Repeat structures of genome yield a more sophisticated DNA representation. For example, the genome of colon Bacillus, Escherichia coli with K equal to 50 has a very complicated De Bruijn graph. Various types of genomes have different assembly requirements depending on specific biological properties. Such is the case for diploid genomes assembly. A diploid genome has a double set of chromosomes and thus has two genomes. This means that we have to deal with two very similar sequences. The task is the same if the two sequences are identical. As soon as those are different, however, or polymorphic, this turns into a real challenge, because every fragment without polymorphism is represented as a repetition on the De Bruijn's graph. Sometimes polymorphisms are so abundant that different fragments may feature random repetitions. Polymorphism is high if it exceeds 0.4%. Which means that every 25th symbol differs. Polymorphism is typical of organisms with extreme level of diversity. Existing genome assembly approaches typically report extremely fragmented contigs. Specific approaches are required. The proposed algorithm, Dispades, is based on the observation that if such contigs are ordered along the initial sequence, breakpoints of counterlateral contigs are far away from each other. With that in mind, we can overlap initial contigs and construct consensus contigs that are longer than the initial ones. To overcome these challenges, we modified the De Bruijn contig and the De Bruijn extraction algorithm to accurately identify overlapping contigs. This allowed us to process polymorphisms of original contigs. So this actually allowed us to construct this consensus model, this consensus line, and then we can divide the original contigs and kind of extract the original structure of the genome. And this procedure is encapsulated in a relevant algorithm. Therefore, our task was to make polymorphism an advantage that would facilitate the solution for us. The immune receptor analysis is another challenge where we have to face polymorphism. In this respect, it is vital to preserve the initial diversity and come up with accurate results. The construction of immune receptors is another challenge. So let's take B lymphocytes. Those are the cells of the immune systems that are responsible for adaptive responses. The ability to adapt is encoded in immunoglobulins and their genes and is represented by a sequence of 360 to 400 letters. Sequencing of adaptive immune repertoires. Today, only this part of the genome allows for successful sequencing, or immunosequencing to be more precise. Every read corresponds to one receptor, and a single receptor can be represented by numerous copies. Thus, repertoire sequencing implies two processes, clustering and an error correction. And to this end, to overcome this challenge, we propose to apply the Hamming graph. In bioinformatics, the Hamming graph is a typical tool for error correction in genome sequencing. More so, it is valid in immunosequencing as well. The Hamming graph has unique reads as its vertices, whereas edges connect in a similar way and have a similar Hamming distance. The threshold value depends on the error rate in immunosequencing data. These graphs allowed us to see that they have a similar structure. I mean, similar reads or identical reads are joined into the same vertices and edges. So this means that this graph needs an algorithm to find dense subgraphs and maximum clicks. And this is what we proposed. The minimal triangulation of such graphs would add just a small number of edges. Therefore, it is very practical. Maximum clicks can be transformed into dense subgraphs. This was the idea behind IG repertoire constructor. It has proved its efficiency. The results are as follows. Those are a number of software platforms that have been developed and successfully implemented. Now they are available for free access to many experts in bioinformatics. These results have been presented to my fellow research community at many conferences that have been regularly published in international journals. May I extend my gratitude to all my colleagues, the colleagues in my laboratory, and my supervisor, Pavel Pevzner. Please, questions to the defendant. Do you have any questions to the defendant? Well, I have many questions. Some of them have already been asked, but this is what I would like to ask. Who of mathematicians in St. Petersburg State University consulted you? Well, none of them comes from St. Petersburg State University because our lab is a new one. It is 2 years old. Well, Well, that's strange. Well, you refer to Nork's paper. Do you know Nork in person? Nork. Do you know Mr. Nork in person? Well, you refer to one of his papers. I think it's reference number 21 or so.
A new genome ensemble algorithm and its application to single-cell sequence.
So algorithms and their application to single-cell sequences. This is my colleague. So this is your colleague who works together with you in at the Faculty of Mathematics, right, in St. Petersburg State University, because he got his degree in 2011, and now he is back to our laboratory. He is working together with us now. No more questions? Quite the contrary, I have some. It's great that you have all these graphs. But do you know such a theory that a graph can be represented as a matrix? Yes, I do know. I'm familiar with this theory. Have you tried to apply this theory to your data? Well, I did. I tried. And actually, the results are reflected in my master's thesis, where I applied the properties of triangulated graphs to the results of this theory, and I developed an algorithms for minimal triangulation. Well, probably this is not so well expressed in your thesis. Well, possibly. Any more questions? That's enough, I think. Are you satisfied with the answers? Yes, I am. Colleagues, questions? Sasiavash, Dmitry, do you have any questions in terms of the report?
The immune system, repertoire construction. Yeah, the main sort of problem there is distinguishing between error and true variance. And you have come up with an algorithm to do that. Can you tell us what are the limits of that error distinguishing? Are there cases where the error and the true variation cannot be distinguished?
Вы поняли вопрос? Пожалуйста.
Мне немножко не очень хорошо слышно, но насколько я поняла,
I didn't hear you very well, but I think that how we can identify errors, right, in sequencing. Well, the thing is that we cannot describe all the errors that are there. Sample preparation includes several stages. Some of the errors are systematic errors, which means that they can extrapolate onto numerous reads, and other errors are unique to every read. Those are the errors of the sequencing. The second type of errors is not a challenge for us because we correct them with dense subgraphs, whereas systemic errors are more important because they can squeeze into these dense subgraphs. And to this end, we developed a specific procedure, the post-processing of dense subgraphs. And we know how to distinguish the reads, the true reads and the error reads, based on the information on biological sequences. And this, however, quite often we cannot distinguish natural variations from sample preparation errors, so we assume that there may be some of those in the constructed repertoire, and to this end we apply triangular procoding or cellular procoding, or on the contrary, we expect to have some artificial variations, and we can just discard it by way of biological analysis. For example, if we construct evolutionary trees, we can see that branches with non-productive sequences that are not expected to generate proteins, so we should not expect those to produce any receptors, and this is how we discard these branches. Could you please be more brief in your answers? Madam Safonova, Savash, are you satisfied with the answer? Are you satisfied with the answer, Savash?
Thank you. Next questions.
Могу я спросить, Яна?
Dmitry,
Да, меня...
Dmitry, do you have questions? Do you hear me? I hear you. Yes, we hear you. Well, my question will be just a follow-up to Siavash's question. But nevertheless, I would like to ask it again. In sample preparation, there are PCR errors that are accumulated equally, and there are also specific areas. Unfortunately, I hear English interpretation at the same time. And there are also hotspot spaces, areas. For repertoire construction,
Вопрос в том, насколько мы способны распознавать хотспоты свойства.
the question was whether we are able to identify the hotspot properties that are typical for PCR. Well, here we see that the dense subgraph is divided into two other subgraphs. What we see here is that the difference between blue and yellow reads, these are the changes in the first CDR. And in that case, this corresponds to RGRYY hotspot. In this case, hotspot and PCR can correspond to natural variation, so that we just prefer not to disseminate these errors. Dmitry, are you satisfied with the answer? Yes, Dmitry is satisfied. Do you have any other questions? No, not so far. Okay, good. Okay, we will join with O'Brien a little bit later. I have a question. Madam Safonova, please, could you please brief, but please tell me the three key benefits, three advantages of your thesis. And I would like each of those advantages to correspond to three subject areas: mathematical modeling, numerical methods, and complexes of programs. So mathematical modeling is the most exciting to me. As for mathematical modeling, I studied the Diploid graph in its application to highly polymorphic diploid genomes and how its structure allows us to benefit from this analysis. So before, there were no efficient methods that would apply Diploid graph to such cases and coming up with successful results. As for the second issue in mathematical modeling, for the first time I suggested to use the Hamming graph to analyze monosequencing data. The Hamming graph has already been applied in genome error correction, but it was also successful in my data. As for numerical method, well, the situation is a little bit more complicated because what I have is heuristic algorithms, and this is due to the fact that the objects that we are analyzing are so complicated that we sometimes do not know their properties, and therefore it is heuristics that guide us only. I have come up with heuristic algorithms that are encapsulated as a software program, and I have spoken about those. Colleagues, we don't see any questions? Do you have any questions, Dmitry? No? No questions? Okay. Then let's start with announcing the reports. May I now give the floor to Siavash. But could you please be short? Could you please be short? Just tell me the key successes and some recommendations, some commentaries. Do not read the full text of your report. Siavash, please, your report. The floor is yours.
So my report was stated that the work is really strong and has been published in the best venues in our field. It's tackling very important problems and is coming up with solutions that are practical and usable. So the results are exciting. I read the English version with the translated version. Compared to what we see here, typically it was a little bit too brief. So in some places I suggest changes to include more details about the algorithms, or attachment of papers with more details, or just clarifications. But beyond simple clarifications, I didn't have any major issues or comments. So that was basically the main points of my report. I'm not sure how much more you want me to say. Is that about the right amount of information, or do you expect me to say more?
Вы закончили, да? Ну, пожалуйста, вы отметили замечания на вашу работу?
Have you finished, right? This is it. You have finished.
Remarks.
Да, какие-то других нету. Remarks, right? No more remarks, or you don't have any remarks?
No. Окей. Дмитрий, пожалуйста.
So, Dmitry, please, your report.
Ряд пакетов для данных тестирования, сборка геномов, репертуар точно не успел сказать, это данных комбинированный репертуар. Но я на второй, третьей частях работы, на сборке репертуара алгоритмов.
There were some problems with interpretation. We have to arrange some technical issues. So I'm going to present my report now. So the author developed a set of software platforms for mass data sequencing, for polymorphic diploid genome assemblies, for immune repertoires and antibody repertoire simulators. Well, there are lots of products of that type, and once in several months we are presented with a new software platform Well, I should admit that the publications are of a very high level, and the results achieved are indeed impressive. So the dissertation is in compliance with the subject area, and the defendant deserves to be awarded the aspired degree of PhD, candidate of sciences in mathematics and physics. Well, there are some commentaries, minor commentaries, which do not spoil the overall impression and do not undermine the validity of the results achieved. Do I have some more time to read out these commentaries? The speaker isn't speaking into the mic. The interpretation of the chairman is impossible. Do you hear me? Do you hear me well? Okay, then I will go across the body of the dissertation. These algorithms were the first tools to solve these challenges. I mean, they were the first tools to construct the immune repertoires as well as to simulate such data. Well, next is quote unquote, sometimes the immune system fails to identify foreign cells, with results in hay fever, asthma, and other allergies, is a very haphazard statement. And the statement that mass sequencing allows to perform full-scale scanning of hypervariable circulating antibody sequences is inaccurate, because B lymphocytes, DNA on RNA sequencing, may include naive B lymphocytes, which are not equal to the set of antibodies produced by plasmic B cells in the bone marrow. A more accurate phrasing would suggest B-cell receptor repertoires or immunoglobulin repertoires without defining those as circulating, because this invalidates the statement. Because just some antibodies in blood can be presented in the sample, but not into full proportion. Next, the statement that, quote unquote, to be able to describe the behavior of antibodies once they encounter potentially malignant agents agents, a combination of SNP and MS technologies is required. This statement is inaccurate. A combination of mass spectrometry and NGS may allow to identify the clones of produced circulating antibodies. However, the antibody interaction with antigenes is not what these methods may describe. Moreover, while all antigenes are labeled as malignant, this is yet unclear. Normal antigenes are attacked by malignant antibodies in autoimmune diseases. Such scenarios are no less relevant as well. The same thing is true about the fact that the immune system fails to identify foreign cells, which results in hay fever, asthma, or allergy. This is inaccurate in any way, because in that case, the infection would spread because it will evade from the immune control.
Причем аллергии не очень понятно. Кроме того, астма в этом предложении поставлена в один ряд с другими видами.
Allergy is here. Why asthma is here? This is all inaccurate, because all these pathologies may have a more complicated processes behind those. But all these commentaries, all these disadvantages are not actually dramatic disadvantages, but what I see is that the author is not well read in immunology. Well, these are my key recommendations. There are some mistakes. And it looks indeed funny when once we start writing about sequencing errors, we come up with spelling errors and grammatical errors. This is indeed fascinating, and this is so regular, regrettably, and unfortunately the author complies with this regrettable trend. But those are minor things, but overall, may I congratulate the author. She made indeed a groundbreaking contribution into bioinformatics. Thank you very much, Dmitry, for your report. Thank you very much for such scrutinized analysis of the immunological part. I should note that it is always a challenge to come up with a multidisciplinary research. Therefore, I intentionally omitted some very specific technical points so as to sound logical. But altogether, yes, indeed, I admit that I'm not too well read in immunology, but I'm doing best to close these gaps. As for the sequencing results, the DNA, the RNA, this is indeed true, but our task was to construct repertoires, universal repertoires. Therefore, we decided to clusterize, to come up with immunosequencing clusters, and then do error correction. And this all works well. Yes, indeed, these algorithms were not the first applied to these tasks, but this is arguable. But because our article, our paper was published at the times when such tools were scarce. For example, Presto had a very limited functional scope. It does not allow for error correction. Maggie, developed by Dmitry, is applied to nano-encoded immunosequencing, which is a different sample preparation protocol. So therefore, we cannot extrapolate this directly onto one another. Well, indeed, such tools are emerging. There are more of them coming now. And therefore, we decided to focus on some comparative aspects between this algorithm and identification of their advantages and disadvantages. Then I would like to comment on combining mass spectrometry and sequencing. Yes, indeed, we cannot say anything about how specific the immune receptor is, judging by these data. We cannot also guess how it binds with the antigen, how the specificity of the receptor works. But we used the data and we referred to Titanus. What we found out is that antibodies in that case are highly likely to be specific to a certain antigen vaccine. This is not a rule, but this happens quite often. Well, this is it, I believe. Dmitry, are you satisfied with the reply? Are you satisfied with the feedback? Yes, I am. Thank you. Thank you. Okay, Professor O'Brien, we are very happy to see you. Please, your report.
Окей, мы вас слышим. Пожалуйста.
So, Brian, Steve, we hear you. Do you hear us?
Okay.
All right, can you hear me? Can you hear me okay?
Yeah, we hear you.
Okay, can you see too? Let's see. Can you see me? No. Okay, you should see now. All right, I read the thesis with interest and thought it was very well written, and I appreciate the depth of analysis and also the depth of care that was taken in preparation. Will you translate what I say in English, or will it just continue? Oh, let's take a break. Okay, I will continue in English. Can you hear me, Yana?
Yes, I hear you.
Can you hear me, Yana? Does anyone hear what I am saying? This is Steve O'Brien. Nobody hears it?
There are some delays and breaks, so I see you, but sometimes I don't hear you.
Okay. Then,
Ну что, закончили, как понимаю.
Николай Васильевич. Николай Васильевич.
ФФН?
Sorry, Steve, we don't hear you.
Яна, у вас... Да нет, не нужно. Я прочитал. У вас отзыв есть, да?
Well, do you have Steve's report? So could you please provide feedback to Steve? Well, unfortunately, due to some technical impediments, I will provide some commentaries to Steve's report. Steve focused on the analysis of complicated polymorphic sequences. I would like to provide some commentaries. The deep space is unfit for all diploid genome assembly. For example, in mammalic genomes, this algorithm does not provide any relevant data. And this is what is actually makes one of Steve's questions, whether we could apply these algorithms to pandas or to vertebrae. Unfortunately, no, we cannot, because in that case, with such high polymorphism, we just are losing any advantages of this algorithm. Steve is also asking what polymorphisms can disk space process, whether those include gene copies variations. Well, my answer is no. This is not within our scope, because in that case we are unable to identify specific areas in De Bruijn graph. What we are looking at is the areas that can be changed, inversions, and to protect to this algorithm, may I say that the genomes that it is fit for feature short polymorphisms, whereas long polymorphisms are typical for more complicated organisms, and in that case we have to come up with different tools for analysis and shift from the contig construction to something different. So different sequencing technologies are used that are more costly, more complicated, but probably allow to deliver successful results. Steve also commented the fact that he did not like the references format, but unfortunately this is the standard requirement, so nothing can be done about that. Well, this is it.
Thank you. Okay, ну там больше...
Well, there are like wishes for the future.
Okay.
Dmitry, your report. Well, I think that everyone knows very well that the topic of the thesis is highly relevant. The sequencing technology allows us to simplify complicated biological objects and to implement calculation computing tools to analyze those. So the expansion of sequencing in the early 20th century brought together biologists, mathematicians, algorithm and statistics experts. And this resulted in the emergence of bioinformatics as a new area of biological data processing. In this research, the author focused on two computational challenges: the assembly of highly polymorphic diploid genomes and immune repertoires construction using sequencing data. Both tasks are joined by one goal: to avoid errors of sample preparation and to preserve the natural diversity of genomes. This is a common goal for many computational technologies in bioinformatics. However, as soon as it is applied to diploid genomes and immune repertoires, it gains relevance. The defendant proposes two mathematical models, De Bruijn and Hamming graphs. I should say that Hamming graph was indeed a novelty, I mean being applied to solve these particular challenges. As for computational methods, here we find two heuristic algorithms. The one is a modification of the Diploid graph for highly polymorphic diploid genomes. And here I should note that we should use the polymorphism masking algorithm. The other is a decomposition of Hamming graph into dense subgraphs. This allows to perform a computational analysis of immune repertoires. These algorithms are the backbone of software programs. Both programs are registered. The defendant also suggested a description of software platforms. Based on these algorithms, those are quite a few. All of those are registered and are efficient. As for the drawbacks of the thesis, I should note that mathematical models lack an articulate description. A set of heuristics is efficient due to the very nature of the analyzed data. For example, the first stage of Dissertation is based on the suggestion that haplocontigs that cover homogeneous positions of a diploid genome will feature distant breakpoints. Therefore, a question: what results should be expected in case of genomes with a higher repeat rates? Algorithms lack evaluation of their efficiency, and the mathematical analysis of the De Bruijn and Hamming graphs is missing. This undermines the value of the thesis as a research in physics and mathematics. Despite the drawbacks, the findings of the thesis are demanded by the fellow community of scientists. The thesis is a multidisciplinary study and complies with the indicated subject. Therefore, may I conclude that the thesis body and findings are in compliance with the requirements for a PhD thesis candidate of sciences in physics and mathematics, while Madam Safonova deserves the aspired PhD in physics and mathematics. May I also add that the thesis is highly complicated, and the drawbacks that I'm speaking now, what I usually do as a mathematician, as an expert in applied mathematics, well, of course, this mathematical analysis would improve, would enhance the quality of the findings, but today we are having a defendant who is a high caliber researcher already, who managed to master such neighboring areas as bioinformatics, immunology. I believe that this is a worthy research and it deserves the aspired degree. So, Madam Safonova, now you can give your replies to the commentaries. Thank you very much, Dmitry. Yes, indeed, in the high repetition rate, the algorithm will not be efficient. Well, I have already provided a similar answer to Steve O'Brien. Because these methods have some limits, the more complicated the genome, the more difficult the processing will be. And in that case, we are likely to come up with unsatisfactory result, and this is common knowledge for experts in bioinformatics. This means that such complicated algorithms need more advanced technologies. As for the mathematical analysis, well, indeed, I take your recommendations, but quite often when we are facing a biological challenge, we have to kind of translate this challenge from the language of biology into the language of maths. And this is what actually my thesis is about.
Задачу сборки диплоидного генома, поскольку
Is about how to formalize the task of diploid genome construction and how to construct the repertoire. Because initially there was no such challenge existing for mathematical analysis. And I think that the future perspective will be extrapolation of this analysis. And this research will facilitate it all in my future endeavors. Yes, I would like to add, I'm generally satisfied, but indeed this is a complicated issue because here we see a multidisciplinary study and these graphs entail lots of problems indeed. But I think that probably this is what makes your team so specific. I see that you have both, but something is beyond the scope of the thesis. But once again, may I repeat it, underline it, but that this is a very deep research. I see lots of challenges and I see huge perspective for this research. Thank you so much, Dmitry. Well, may I now announce my report? And as a chair, I'm not going to read it all out because it is published on the website. And I believe that members of the Dissertation Board had an opportunity to familiarize with my report. I'm not going to praise the thesis. I'm not going to shower it with compliments. What I may note is that it deserves the aspired PhD degree, no doubt.
Я имею в виду степени кандидатов из матнаук.
In the subject of physics and mathematics. However, as a member of the Dissertation Board and a member of the Dissertation Board at the Dissertation Supervision Center, I was among those who developed the requirements to the dissertations presented in this subject 051318 mathematical modeling, numerical methods and complexes of programs. And this means that such dissertations should have all the three methods: mathematical modeling, numerical methods and complexes of programs. I have already sensitized Yana to this issue, and may I also highlight this once again, that of course this thesis is more into bioinformatics, but Yana is a very laborious researcher. So we have discussed this issue not but once before the defense. Nevertheless, as an applied mathematician, and this is what Dmitry has already said, I really have not found any profound analysis of mathematical models. Well, graphs, this is what Dmitry has already said. We could have presented these graphs as algebraic methods. Well, yes, of course, this algebra and so on and so forth, and lots of other things. I do not fully agree with you, but we will discuss that on the margins later. Also, what is missing to my view is algorithms, the structure of those algorithms. And, well, why not do that, actually? Well, next, This computational technologies, parallel computations, possibly the program that you have come up with, well, you could have provided some more elaborate analysis of that. I indeed understand that probably there was a whole lot of people who did that, or probably you did that to order just for some commercial purposes. But as an experiment, as soon as you are doing an experiment, as soon as you are engaged into research, you should have been more elaborate, and you should have looked at the requirements to this specific subject area. This is what is about criticism. As for some positive aspects, well, first and foremost, I see that Madam Safonova is a profound, a high-caliber scientist. Her approach is indeed unique because she is so much sensitized to this problem, to this matter. Of course, it's no doubt that she has developed a unique software platform, and this deserves the superb and the utmost, the top evaluation. Well, despite all the body of criticism in numerical methods, in compliance with the subject area, nevertheless, I believe that Madam Safonova deserves the aspired PhD candidate of sciences in the aspired subject area, mathematical modeling, numerical methods, and complexes of programs. You may now provide some feedback. Well, of course, I take it all in terms of the style of the dissertation. And, my challenge was to describe some non-trivial biological objects, and I was looking for some compromise, some golden middle. Well, I understand you. I know what's it like being in your feet. Well, we are practical, and first and foremost, we start from the challenges. And then once we have these challenges, we are able to propose some basic solutions. And we will be developing the computational analysis as well. This is the horizon for the future. Distinguished members of the board, distinguished colleagues, members of the audience, is there anyone who would like to take the floor to ask questions? Just a couple of words. Well, I have already said that, well, I disagree with you, Mr. Chairman, but now I should say that I almost agree with you, Mr. Chairman. But here, I think as for the subject area, Yana should have distinguished between all the three components within this subject area. And we have discussed this not but once before. But what we are doing here, we are providing this just general assessment. Therefore, I think that the dissertation complies with the subject area. Yes, indeed, what you have is what you have. Colleagues, members of the audience, Dmitry Siavash. Oh, Mr. O'Brien, do you have any comments? Would you like to add anything, to ask anything? Nothing, right?
I'm pleased with the presentation and I'm really and your colleagues for a very nice presentation.
Ты поняла? Я не понял.
Не расслышал.
Я прошу прощения, но у нас
Thank you very much.
не было возможности.
We are so sorry, but we couldn't hear you. We were unable to hear you because it was almost scrambled.
I'm sorry, Steve, but it's very bad connection between you and us, and unfortunately, I cannot hear your question.
Нет, ну нет. Окей. Коллеги,
Okay, the report of the research supervisor. Paul, his candidate of physical and mathematical sciences, head consultant in the algorithmic technologies laboratory in St. Petersburg State University. He's the research supervisor. Well, he has not found any flaws in Yana's research, and he underscores Yana's the advantages of the thesis. He deems that the topic is highly relevant, and the results are fascinating. They are very much awaited by many laboratories in Russia and internationally. Immunology laboratories, the laboratory of biology of inflammation processes by Klaus Lahoudier, and other commercial companies. What he notes also is that the results are very well elicited and very well presented in peer-reviewed journals that are registered within Scopus and Web of Sciences. This indeed indicates that the thesis is in full compliance with all the requirements, and he provides full support to his postgraduate. I believe there are no questions to the research supervisor. In compliance with the procedure, Madam Safonova, you now have an opportunity to reply to all the comments that you failed to provide with a satisfactory answer. If you think that all of the commentaries were provided with some feedback. Okay, yes, indeed, this is how it is. Now, dear colleagues, we are having a 5-minute break. Only members of the dissertation board stay in the room, and there will be the voting procedure, pass or fail. Okay, 5 minutes break, and then we resume the session. Thank you. 5 minutes break. colleagues, we can resume our work. Colleagues, do you hear me? Dr. O'Brien, Dmitry, Siavash. So now we have to decide, pass or fail. Dr. O'Brien is in favor. Pass. Dmitry, pass or fail? Да. Siavash.
Я тоже. Ну и тогда...
So do I. Okay, unanimously decided. And this is the conclusion on the dissertation by Madam Safonova, submitted for the PhD candidate of sciences in the subject area 051318. The results of the voting procedure. The dissertation is in full compliance with the relevant PhD awarding procedure in St. Petersburg State University in the subject area mathematical modeling, numerical methods and complexes of programs. The defendant has provided the papers published in the list of journals that are included into the register of the Higher Attestation Commission of the Russian Ministry of Sciences, and therefore the decision is made to award Yana Safonova the aspired academic degree of Candidate of Sciences, PhD, in the subject area 051318 mathematical modeling, numerical methods, complexes of programs. Voting. Who is in favor? Who is in favor for this conclusion? Dmitry. Thank you very much, colleagues. Thank you very much for your cooperation, for your contribution. So see you sometimes later. See you. Goodbye. See you, dear. Goodbye, dear colleagues. Now we can invite the members of the audience. Thank you, friends. Bye-bye. Goodbye, friends. So please be seated. May I inform members of the audience that members of the dissertation board have come up with the following decision of the dissertation board. May I read it out? The decision of the dissertation board on the thesis submitted by Yana Safonova in the subject 051318 mathematical modeling, numerical methods and complexes of programs, that was defended on April 17, 2017 in St. Petersburg State University. Is in compliance with the stipulated PhD awarding procedure in St. Petersburg State University and is in full compliance with the subject area. The defendant presented the papers published in the research journals included in the register of the Higher Attestation Commission with the Ministry of Sciences of the Russian Federation. Therefore, the dissertation board decided to award Yana Safonova with the PhD degree in the subject area 051318, mathematical modeling, numerical methods and complexes of programs, unanimously. The decision is made unanimously. Madam Safonova, may I congratulate you with the academic degree and wish you all the very success in your academic endeavors. Thank you. Yana, please come closer. And we will just make a photo. Yana in the middle. The dissertation board session is adjourned.